Hi everyone, in this video I want to talk about adding and subtracting radicals. Here are the two problems that we'll do, and to make sure we don't take ourselves too seriously, here is a fun question to think about throughout the video. If you could pick a different century to live in, which would you pick? So we have some interesting looking problems here, and it says simplify. So we have adding and subtracting in the first and subtracting only in the second. There are a couple of things that we should talk about first. So in order to add and subtract radicals, I want you to think of the Algebra I concept, just, combining like terms. 5x plus 3y plus 2x plus 4y. Okay. You can only combine the terms that will match. So that would combine to be 7x plus 7. I want you to think of this radical as basically like a like a variable. It's not a variable, but I want you to think about it no differently than this. So the way that I kind of see this before I start is like this would be negative 3x plus 3y minus, say, z. Those three terms are not like terms. So right now, nothing is able to be combined. Nothing matches. But if we know a thing or two about simplifying radicals, these parts, these square roots by themselves, the 6 can't go further. Then we could use the techniques that we understand about simplifying first. So, two options for simplifying, and I do have a video on this. Let's take that square root 24, a really good example. I could do a factor. I could do, that's 2 and 12, that's 2 and 6, 2 and 3. The square root of 24 is, I'll just write 2 times 2 times 2 times 3. Remember, we need the prime factorization, so the prime number factor. And anytime you have a double, you need to pull a single out because it's getting square rooted on its way out. That's 2 root 6. A much faster way is to pull out the biggest perfect square. We have root 4, root 6. Oh, that's just 2 root 6. They both give us a 2 root 6. One process is a lot quicker than the other. And if you need more of an explanation on that, feel free to see my simplifying square roots video under Algebra I or simplifying cube roots video in the Algebra section. Okay, so what I want to do is probably try not to do the long way. Okay, some people like that way. But let's try this second method of just taking out the largest perfect square. For this, both of these examples, we should probably have the perfect squares as our options written out. I'll write out more if I need to. Looks like I don't need it because this 24 and 27, we wouldn't need anything greater than a 25. And then because I have cubes going on over here, let's write out all the cubes. Okay, so 2 cubed is 8 because 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 is 16 times 4 is 64. And I'll stop at 5. 5 is 125. Okay, so I'm going to choose for root 24, like I did before. The largest perfect square that can come out is a 4. what's left over when you pull a 4 out? 6. That's negative 3 times 2, root 6, simplifies to negative 6 root 6. Remember that negative 3 on the outside, you multiply. Multiply that in. Then this 3 comes down, like there for the ride next to the root 27. The root 27 is just 9 and 3. So that's 3 times 3 root 3, which is 9 root 3. This right here, I like this example because I can show you that there is a sneaky little 1 right there. It's like I was likening this to variables earlier. This would be like thinking of it like a negative 1x. Okay. So I do have to think about the 1 being there. I think I'm going to leave it there. So I'm going to bring down a negative 1, or well, minus 1 root 6. So it looks like I do actually have like terms. It's almost like this is negative 6x, this is minus 1x, and then this would be like a 9y. Think of it like that, where we have like terms. Okay, so I'm going to combine these root 6's together to be negative 7 root 6, and then this 9 root 3 doesn't have a counterpart, but it just comes down. And that's my answer. So you need to simplify the radicals, then combine them at the end. With cube roots, so this has a cube root part as well as square roots. We do need to make sure that we combine the like terms again. So I'm going to simplify the cube roots and see if I can get anything to match. So 3 comes down, it's there for the ride. I'm thinking about what goes into 135 that is a perfect cube. And it looks like, after messing around with my calculator, that a 27 can actually come out, because 27 times 5 is 135. That is a cube root of 3, cube rooting that 27, and then cube root of 5 comes down. This is 9, cube root of 5. Then so 81, 81, you can also divide out a 27 there as well. So I'm going to take the 27 out. What's left over? 3. So that is negative 2 comes down. This is 3. And then cube root of 3 for the ride. This is minus 6. And then there's a cube root of 3 at the end. Now this, so, oh yeah, I could do this square root 12, right? Minus 2 root 4 root 3. That would be 2 times 2 root 3 minus 4 root 3. Okay, so now I'm trying to think about what matches. These two match. This does not. So I'm going to combine those. That's 3 cube root of 5. Oh, I take that back. The root 3 and root 5 do not match. So guess what? That's my answer right there. Nothing matches. A cube root of 3 and a square root of 3 do not match. And then this cube root of 5 and cube root of 3 do not match. So you actually just simplify everything down for this one, and then that is your final answer. So I chose a few practice problems. I'll circle this. I chose a few practice problems for you that are pretty similar to those. Let's have you try these two. And in just a second, I will give you the answers. If you did them correctly, your final answers would be these. Notice there's only one term for this answer. That is a root 6, which means that all 3 of these would end up being root 6, basically like the like terms that would have the root 6 at the end. So I hope this video helped you in some way. Let's leave you a quote for some inspiration. Don't judge me by my successes. Judge me by how many times I fell down and got back up again. That's a Nelson Mandela quote. that I really like. And I hope you have a good day. Make sure that you comment with the fun question if you are so inclined. And feel free to subscribe if I can help you in the future as I upload new videos. Thank you.